These are your 1A notes, and we're going to talk about operations with polynomials. Today we're going to talk about monomials, and we're going to define what a monomial is. We're going to add, subtract, multiply, and divide them. So a monomial, mono means one, so it's an expression that's a number, a variable, product of numbers and variables, and so it's one term. Another way we call monomials is a term. So I'm just going to give you some examples and some non-examples to help you understand that. So a monomial can be a number, just as simple as 5. It can be a variable, as simple as x. It can be a product of numbers and variables, like 5x, so being multiplied together. And you can do several different variables together, so like a 3, x squared, y cubed. That's all multiplication. That's a 3 times an x times a y times a y times a y. It could be negative. They can be fractions. So a fraction is a number, a fraction times x. Now sometimes when we see this, 1/2 x is sometimes written as x divided by 2, and it looks like division, and it's not. It's really the multiplication of 1. So that one's kind of tricky because people think that it's not a monomial because it shows division. So what's not a monomial? If you're going to take a variable and a number and add them together, that's the addition of two monomials. X is a monomial, 5 is a monomial, but we don't call those monomials. That's actually a binomial because there's two terms, and we'll talk about more of that later on. If we are subtracting variables and numbers, and if we're dividing, now division is when you have a number and then the variables in the denominator, or a variable divided by another variable. Not allowed. That's the division of two monomials. But the division on this side was okay because we were dividing by a number, and when you divide by a number, we can rewrite that as a multiplication. So monomials, think monomial multiplication. Everything has to be multiplied together. Some terminology for you. First day of the new chapter, so a lot of terms. You guys can pause here to write these down. A constant is a monomial that has no variables. It's just a number. It's not going to vary. It's going to stay that number consistently, so that's why they call it a constant. Coefficient is the fancy name for the numerical part of a monomial. So whatever the number is that you're multiplying the variables by, that's the coefficient. And then degree. Degree is a way to sort of rate monomials. You can put things in order when it has degree as a rating. And what you do to find degree is you add up the exponents of the variable. So 3 key words there. The sum, we're going to add up the exponents of the variables. That's how you find degree. Degree of non-zero constants is 0. So if you have a number, there is no variable. So the degree is 0. And 0 doesn't have a degree. So we're going to quickly go through this table, fill it in, talking about those terms, what the variables are, what the coefficient part is, what the monomial is, what the exponents are that we're adding to get the degree. So the first one, the first monomial is m. It's really a 1m to the first. So don't forget that when there's not a number out in front, it's implied that it's a positive 1. And if there's no exponent, it's implied that it's a 1. So my coefficient of m is 1. It's the numeric part of the monomial. My variable is just m. The exponent is 1. And so my degree is 1. There was no exponents to add, so you just take the exponent of m. So m has a degree of 1. It's to the first degree. Negative 7a squared, the coefficient would be negative 7, the numeric part. My variable is a. The exponent is 2. And again, my degree would be 2. That's a second degree monomial. The next monomial is the multiplication of x cubed times y squared. Again, there's a 1 out in front, so my coefficient is a 1. My variables are both x and y. X has an exponent of 3. Y has an exponent of 2. So if for the degree, I would add those two exponents together, and the degree of that monomial is 5. Negative 4, its coefficient is negative 4. There are no variables. So if there are no variables, there are no exponents. So it has degree 0. And then n cubed, that's an n to the third, p to the fourth r, all divided by 3. Remember, when it's divided by 3, it's really the multiplication of 1/3. So the coefficient would be 1/3, not a 1. You got to take the 3 into consideration there. Variables are 3 of them, n, p, and r. And I have 3 different exponents. I have a 3, a 4, and the 1 from the r. So my degree, when I add those all up, is 8. So that's a summary of all of the coefficients, exponents, degree, a lot of terminology there. All right, we're going to go through all the properties of powers. These are from Algebra 1. I'm going to go quickly. I'm going to define it, and I want you to understand the expanded form and then an example. We can expand things out. We'll do that in class, but I'm going to give you the definition of these rules, and I'll show some examples where you can expand it out. The product of powers is basically telling us that if you have x to the 5th, actually I'm just going to use a to the mth times a to the nth, a to the m plus nth. Okay, that is the product of powers. So if you're multiplying and you have a common base, you just add the exponents. So to give you an example, if I have x to the 5th and I'm timesing by x to the 3rd, I can just add the exponents. That becomes x to the 5 plus 3, which is x to the 8th. Okay, and to show you an expanded form, I'd have 5 x's here multiplied together. That's what x to the 5th means. I'm multiplying 3 more. It's all multiplication. There's a total of 8 x's there. So on the bottom there, I showed expansion. You're more than welcome to expand these. The expansion is why the rule works. Quotient of powers, if I have a to the mth, and I'm dividing by a to the nth, a represents the same number. It can be a 5, it can be an x. So as long as you have the same amount on top, the base, as you do on the bottom, you can subtract the exponents. Since quotient means divide, division is the inverse of multiplication, so we're going to subtract the exponents rather than add them. To give you an example with variables, x to the 5th divided by x to the 3rd, I can subtract the exponents and I get x squared. To show you an expanded form, I have 5 x's multiplied on top. I have 3 more x's multiplied together on the bottom. But anytime you get an x divided by an x or a number divided by itself, it turns into a 1. So these 3 all turn into 1s. So 1 times 1 times 1 times x becomes x squared. So again, you can expand it out. The expansion is what the rule is based on. It allows you to not have to expand it, but there's no rule that says you can't expand it. Power of a power, you are raising a power to another power. And when you do that, a power to a power, we actually end up multiplying the exponents. It's the shortcut. I show you an example. X to the 5th to the 3rd power. That really means x to the 15th. If I were to expand that out, and you really think about what does it mean to take x to the 5th to the 3rd power, it means multiply x to the 5th by itself 3 times. And if I really wanted to, I could write down 5x's here, multiplied together, 5x's here, multiplied together, and 5x's for the 3rd one multiplied together. In the end, I have 15 x's listed there. So you could expand it all the way and write down 15 x's. I could also say, oh, I'm multiplying here. So I change my power to a multiplication problem, and then I add the exponents, 5, 10, 15. So lots of different ways to do these problems. If you're taking a power of a product, that is where you have an a to the mth, a b to the nth, and then you're raising that product, that multiplication, to another power. So basically, if there's more than one term that you're raising to the power, you just, in a sense, apply that power on the outside to every term inside. So it would become a multiply m times p and b to the n times p. So as an example, it would be x cubed y squared. And if I were to square that, it would become x to the 6th, 3 times 2, and y to the 4th. I could expand that just like we did before. If you're taking a power of a quotient, that means a power of a fraction. So if I have a over b, and I'm taking it to some power, say m, that power applies to the numerator, a to the mth, and it also applies to the denominator, b to the mth. So if I have 1/3 squared, I am going to square the 1, and I'm going to square the 3. This applies to numbers too, so I wanted to throw a number example in there because everything I've talked about works with numbers as well. 1 squared is 1, and 3 squared is 9, so I get 1/9. A negative power, if I have a to the negative mth power, whenever you have a negative exponent, it actually ends up flipping, taking the reciprocal of the base and then raising that number to a positive. So by flipping it and taking the reciprocal, it makes my m turn into a positive. Now, if the negative was in the denominator, I want to mention that if it's negative and it's in a denominator, it just flips up to the top to be positive. So to show you this, x to the negative 5th power is equal to 1 over x to the 5th. So it flips and turns positive. Anytime you raise any number to the 0 power, it turns into 1. It has to do with the powers of 10, our base number. We have 10 digits in the entire US or our number system. So our whole number system is base 10. We have a tens place, a ones place, a tens place, a hundreds place. And so everything revolves around base 10. And so if I have a huge number raised to the 0 power, it's equal to 1. If I have an entire quantity, x cubed y squared over z to the 4th, and it's all raised to the 0 power, then it all turns into 1. I can explain that a little bit more tomorrow in class as to why that happens, but it's just something you're going to have to memorize at this point. So a couple key elements when you're simplifying. We're going to be simplifying today. We got to follow these rules. You can't leave a problem as a power of a power. So if there is an exponent being raised to another exponent, you need to take care of that. You need to multiply them. Each base appears exactly once. So if there's 2 x's, whether it's being multiplied or divided, I need to put them together. So x can only appear once, y can only appear once. If there's more than that, we know we got to do some simplifying. We're trying to make the problem look simpler. Fractions need to be in simplest form, so you need to simplify. If it says 5/10, you need to write 1/2 and no negative exponents. We always get rid of the negatives. We always report our answers with a positive exponent. So it's kind of a checklist to see, are we simplified? So we'll go through a couple of examples here. We're going to simplify. So lots of different ways we can simplify. There's more than one right way. In this particular example, I see that I have a couple bases of A, and then I've got one base of B, and then I have a C with a negative exponent. So the parentheses next to each other, all the numbers written next to each other, shows me that this is one great big multiplication problem. I can expand it out. I like to, as a personal preference, get rid of my negatives right away. So what I like to do is I sort of make a fraction bar when I see negatives, because I know things are going to start flipping. So a to the negative 3rd becomes a to the positive 3rd on the bottom. A squared stays on top, b to the 4th stays on top, and c to the negative 1 becomes c to the positive 1st in the bottom. So I did that one step, and then at this point I could expand, I could use rules. So I can see that I have 2 a's on top, and on the bottom I have 3 a's. So I'm using expansion here. And when I do that, I can see that 2 of my a's are going to turn into 1, simplify into 1, and that leaves me an a in the denominator. So my final answer here is b to the 4th over ac. I look at my rules of simplifying. I don't have any negative exponents. I only have one base each. Fractions have been simplified. Everything's pretty. Just want to reiterate, there's more than one way to do this problem. So if I started here, I could have divided the a's. I have a common base, and I'm dividing. So I could actually subtract their exponents. It's always top minus bottom. So 2 minus 3 would give me a to the negative 1, b to the 4th, over c. I can't leave my answer like that, so the very last step I would have to do is to bring that down on the bottom. So I'd end up with the same answer again. And one more time, one more way. From the very beginning, I'm multiplying. I have an a to the negative 3rd times a to the 2nd. I could add these exponents, and I would get a to the negative 1 times b to the 4th times c to the negative 1, which, when I simplify that, b to the 4th will stay on top, and a to the 1st and c to the 1st goes to the bottom. So again, I showed you 3 different ways in 3 different colors how to simplify that problem. And you're going to have to figure out which one comes to you first. If you're thinking multiplication, then go for it. If you want to get rid of your negatives, go for it. Okay? If you want to expand, that's fine. My only suggestion is if you expand, you want to have things in the positive form. For number 2, I have division. I have division of a common base. So I'm going to subtract. So I'll get n to the 2 minus 10 power. That's n to the negative 8 power, which I can't leave it as a negative. So to simplify that, I flip it and it becomes positive. Okay, another way to do that problem would be expansion. I have 2 n's on top, 10 n's on the bottom. 2 of those n's are going to turn into 1's. Whenever that happens, you got to have a placeholder 1, right? There's always a coefficient of 1. It doesn't disappear. And so I have 1, and then I have 8 n's left over. So 1 over n to the 8th. Okay? The whole idea of the rule is so you don't have to expand, but sometimes that's the best way. Then you won't make mistakes. For number 3, I got to apply that power to every single problem inside the parentheses. Even the 3. The 3 is raised to the 1st power. So I'm going to square the 3. I have to square the a cubed, which is a to the 6th. And I have to square the b to the 4th, which becomes b to the 8th. Remember, a power to a power, you multiply the exponents. You might want to have your tools handy as we do the homework. So the only thing I had to simplify here is this 3 squared. I know that 3 squared is 9. A to the 6th, b to the 8th. If you're not a big fan of that, you could have expanded that power and explained what does it mean to square something. To square something means to multiply it by itself. Okay? And then you could even take it a step further and expand more. You could put the like things together. So I'm going to let us play with this, kind of go through it, and then we'll see what happens. We can go over some more strategies in class as we continue. A couple more problems here. For a negative exponent with a fraction, you can distribute. Remember, there's a 1 here and a 1 here. So we're multiplying. So I get 2 to the negative 3rd over 3 to the negative 3rd. They're both negative. So that means my 2 to the negative 3rd is going to go to the bottom to become positive. And my 3 to the negative 3rd is going to go to the top to become positive. 3 cubed is 27. And 2 cubed is 8. Another way to do that problem, just going to throw this out there, we could take care of the negative itself. So since it's applying to the entire fraction, if I flip the fraction first, now that becomes a positive 3. Then I take the power of the power, 3 cubed, 2 cubed, and I still end up with 27 over 8. So you're just going to have to figure out which one works best for you. All right, number 5. I like to show, number 5, I like to work in the positive. I see all these negatives, so I'm going to write my fraction and then put things where they need to go. Negative 5 stays on top. It's raised to the 1st power. A lot of people see that negative and they think that they have to flip it because you can't have a negative in the, or you have to flip it. 5s can be negative. You can't have a negative exponent. So keep that in mind. We start to get a little tricky here in our thinking. X cubed goes down below. X squared stays down below. y to the fourth goes down below, y to the sixth stays down below. Z squared stays up top, and z to the first goes up top. So now your like things are put together. Don't forget about simple fraction simplification. A negative 5/10 becomes a negative 1/2. Z squared times z, that means that there's 3 z's on top. I have 5 x's on the bottom, so x to the 5th. And I have 10 y's being multiplied together in the bottom. So that is my simplified answer. There's more than one way. I'm going to spare you doing it another way with the complicated problems. Okay, number 6. A couple different things here. I'm going to show you, you could distribute this power through, you could distribute this power through and go from there. Okay, another way, I'm going to show you the expansion. If I'm squaring a 3RS, that's a 3RS times a 3RS, and then times an S cubed T times an S cubed T. Now, before I even write the denominator, there's a better way to write that problem. I could have, when I squared the 3, just said 3 times 3. They're going to be multiplied together. So put them next to each other. The R and the R are going to get multiplied together. The S times the S are going to get multiplied together, along with the S cubed and the S cubed and the T and the T. So as you expand, you can kind of regroup and put the numbers with the numbers and the like variables next to each other. It's just going to help you organize your information. And then I have 12 S squared T to the 4th. I'm going to put together the top. So I've got 9 from my 3 times 3, R squared from my 2 R's, and then I have 1, 2, 3, 4, 5, 6, 7, 8 S's, and I have T squared over 12 S squared T to the 4th. Think of this fraction in different parts. You don't have to necessarily write them down in different parts, but simplify 9/12. R squared doesn't really have any other R's. S to the 8th over S squared and T squared over T to the 4th. So if you put the like things together, you can kind of do that in your head. Don't forget about the 9 and the 12. A 3 can be taken out of each. 9 divided by 3 is 3. 12 divided by 3 is 4. R squared remains the same. S to the 8th and S squared, I have 8 S's on top. I have 2 on the bottom. That means 2 would cancel, so I'd still have 6 left over on top. Kind of, you can expand in your brain as well. If you look at the T's, I have 2 T's on top. I have 4 T's on the bottom. So when I'm all said and done, I will have 2 T's on the bottom. And there's your final answer. All right, so what I need from you is for you to determine the degree of that monomial, and then I want you to simplify that fraction, and we'll go over the different ways, and it'll be a good discussion for us when we get into class.